So let's get started. Maybe just some main issue first is because next week is hiking holiday. So we don't have class, right? It's a public holiday. It's Chongyang. So there's no class. So I mean, because of typhoon and then we have this, then we have somehow to make up. So probably you know this that we have these two classes to make up there. So I want to, if to make up, we want to make up the same day. So I want to make it like Saturday. And of course, in the case that I know some of you actually not live in Hong Kong, live in Shenzhen. So you can just attend in Zoom if you don't have time. For that 2 mega class, I mean, I don't care about attendance. I will still be in the room, of course, but if you are busy, you can do that. Of course, there's a limited spot in other section, so you can also attend if you really like in person. But I will be there, and if you don't want to attend the Zoom. But we'll go back to the WM1 because I think this room is very competitive to go. So we only able to book the first one, but we'll go back to the WM1. I think we should see the campus. This is already in the platform. Yeah, I'm sorry about that, but I think this room is better in terms of your computer. If you forget your laptop, you still can work out. But there's a limitation that what we can do. But let's see if we can book. So today the main goal is to finish the lesson 3. Okay, and then to give you some idea for the if you have time, we will go through the rest of the course. And we are lesson 4 today, but probably you do notice that we're still in the lesson 3. So probably we are like one class behind. But I'll tell you what. Maybe we skip some of the material, but I'll tell you later what we may be skipping. But let's return to lesson 3. So if you recall lesson 1 and 2, right? Lesson 1 is basically understanding the data, and that is, I guess, turned out to be the single most important thing in fact, if you're not aware of that, because we never thought about how to collect data, how to clean the data, how to filter data. And lesson 2, we learned some basic data analytic tools. If you still recall, right? If you look at our slide, right? Lesson 2 is focusing on the case where how you can do EDA and how you do correlation between 2 variables. And today's, lesson 3, I will extend what we learned by estimation. The 2 things you learn for estimation is a hard estimate and interval estimate. And then we'll learn also about hypothesis testing. So after today's class, I think we are ready for your first assignment, which would be Python coding. So basically, we focus a lot of Python in the class, so probably I'll ask you to write down Python code. Don't worry, you'll be very similar to the thing we do in the class. So if you're able to follow, that shouldn't be the same sum here and there. But that would be make sure that you're okay with the Python code. So the main thing actually we do is estimation, or you like prediction, is based on data. Okay, we're trying to guess what actually happened. Like we have the sample mean, right? We try to guess the population mean, right? There's a main idea that this compute on estimate, and that is very simple, right? What the easiest way to extend our knowledge from the data to the population, right, is the idea that actually the data is representative. So the data you got is actually what's supposed to be in the population, right? The idea is like, right, you're IT manager, right? If you try to think, okay, what is the traffic to the website tomorrow, which is Saturday, and then you use last Saturday as a benchmark to form the guess, right? What is the average traffic? Last Saturday will be your best prediction, right, or best guess for the next Saturday, right? So that would be the idea, right? It's like this is the point estimate. But it's not sufficient. Usually we would, because just one point is not sufficient. We don't know how accurate our guess is. That would be idea of this, how reliable our point estimate would be reflected what we call interval estimate, or what we call confidence interval, which we will give in more detail. Okay. So let's get to the, I think one of the easiest scenario is guessing number of days that has 5% loss, right? And this is the idea is getting the mean, right? Because of guessing every single day, right? What is given each day is 5% loss is the average, right? It's a proportion, the number of total of days, right? So it says this is the population mean, right? Can be considered. We can use the sample mean to form a guess, right? So that was what we do last time, right? It's like we download the SP500 data from this one, right? And then we do the data cleaning, right? We have the stock data and replace NA and drop NA and result index. After we do that, right? We did the following, right? I think we just stopped here last time, right? I think we stopped here last time of the code lab. That's what we left, right? We calculate this return, right? Using the percentage change. Okay. Then we drop the NA because the first observation is indeed NA there if you calculate the return. Okay. And once we do that, then once this is the return, is the data that we want to analyze, right? This data, we have return data. And we want to look at how it looks like first, right? Here the histogram, I think it shouldn't bother you how to draw the histogram. And particularly, you see each day, how many percentage are less than -5%, right? You can calculate the percentage, right? Because here I use the I think I use a density. Maybe I use density. True. And then you should give me the density plot instead of the I think I have to run all the way up to here. The reason to complain because I didn't drop NA, so the max and the mean has an issue. So you'll probably see why I have to drop, because when you have data when you don't drop NA, then they can't do the mean max. So it's not something that I do extras that has some meaning. Okay. So it becomes the frequency, right? So you will see this amount of data in relative terms is less than 5%, right? And then you count how many days, right? Over total number of days, that is the mean of the thing you want to measure, right? So so that will be the best guess, right? If you look at data, how many days that is less than 5%, more than 5% loss is 0.5% days, right? If you are going to estimate this probability, that's the best guess, right? Because now you actually look at the days whether more than 5% or less than 5%, right? Because remember, when you how you calculate this number, right, is you would, right, look at each day is whether less than 5% loss or not, right? The loss is exceed 5%, right? And it become a 0-1, right? Each day is either 0 or 1, right? If less than 5% loss is 1, right? It's binary data. Then binary data, the mean is just the proportion. It's a bunch of 1 and 0 and divided by how many of them is proportion. Right? So for proportion data, then you can calculate is 0.5%, right? So this is the best guess. So if you try to assess, right, how risky is this? Is at 0.5%. Okay, but this is only give a point, but usually we are not told how good is this estimate, right? If you think about this, if you think, okay, I invest this US stock for like 4 years, right? The 4 years is equivalent to say 1,000 days. Each year only around 200 something trading days. And say for 4 years of time, there are 5 days that I have a big loss like that. Okay? Then you would think whether this is going to be a risky or not. Right? Maybe 5 years or 4 5 years. Each day, 1 day like big loss. Then you will assess whether this high risk or no risk, I don't know, but that is what we have. But the question would be, is it 1 day loss per year for every 5 years? So is it a good, right? Every 5 years, 1 day of big losses. The question would be, depends on how reliable of this point estimate. And how can we assess this variation, right? Because what we have is just one number here, right? We have such one number here, okay? How good is its estimate? Okay. And the question is, it's hard to say without further assumption. We have to make some assumption. Because like, it's unlikely, you do experiment, you go to the lab, you can repeat many times, right? Or medicine experiment, you can feed people with different drugs and you can check. But like websites or history or stock price, you can't really repeat itself because in general, you really can't do it. Okay. So how can we solve this problem? And that is by the assumption that you are doing a random sample, you're collecting data randomly from what you want to do. Okay? Or we are thinking we are in a universe which is not so special. There are many multiple parallel universes in us. We are just in one universe. Okay? By making this assumption, okay, and different universes are very similar. Okay? That's not so special. And by looking at how the variation in data can give us how good the variation in different universe, right? Look at the data, how spread out is in our universe, can give us guideline and how other universes behave. Okay? In some sense, it's like if your data, okay, to make it simple, imagine your data is very concentrated, right? Then it would give us some confidence about maybe other universe will be also very concentrated. And then our data actually is a very representative, it's very accurate and gives us a good guidance. Okay? And as we see, the confidence will be very small, right? If the data is is very diverse, then the conclusion we can draw from the data cannot be as common as we want to. Okay? Because say there's a lot of variation in the data we have. Then you can imagine that other universe, hello universe, can be very different. Okay. So that is the main idea, right? Because the data we got in theory is a random variable, right? Is something that depends on what sample you got. Okay. As long as you draw the sample as representative, it's a random sample. So then it would the sample mean would follow some nice property. Okay. So as I said, we want to assess how accurate the point estimate. We want to look at how actually this random variable is a standard deviation of this. It's like how variation of this. Okay. But this part is how can we do this, right? Because we don't know how to measure it. Okay. But we know that if this is very concentrated, then it's okay, right? But otherwise, we don't have any good idea. Okay. So how are we going to do? Okay. Is by using confidence interval, okay, telling us that u plus minus 2 SE, then you'll be fine. Okay. The idea actually follow from the central limit theorem saying that everything follow normal, so 95% actually follow in the within the bell curve. Okay. So maybe I just a little bit give you some more background, right? Because that hopefully will give idea what we are doing. Okay. So we can always imagine that what we try to study is a population. Okay. This blue one is called population. So I have a pen here. The pen is here, but I don't know whether it can be written nicely. Okay. Population is the things, the big picture or the big conclusion we draw on, right? Suppose I want to look at maybe this is the website traffic of all population in China, right? But the problem is we are not able to ask for everyone in China. Instead, we have to do some sample. It's a red one. Okay. Right. I think this is right. Chinese. Yeah, right. Then you but this sample depends on it's a random, right? Because you may draw this guy, right? You may draw the other guy, right? That and many possibility that where you can draw, right? That means that but I only get one, right? Remember we get it. Based on this sample, maybe say we have a sample mean, right? The sample means to guess what happened to the population mean, right? So what we do is, right, actually, right, what we get is we from this data, we have the sample mean, right? This is what we get, right? This number of days that has lost more than 5%, right? And we want to guess, right, in the big picture, what is this mu is the actually was the probability that you can have lost more than 5%, right? It's from data. It's actually what we guess, right? We want to use this to guess. Okay. And because we only have one sample, of course, this is our best guess. Right. And if you learn the you call undergraduate class, then actually you can have many samples if you have. And average of this, we get you this one, that's called unbiased, who can there's many probably we don't want to talk about that, but this is a good way to get this guy. Okay. And other property like consistency means if you expand this infinite many, this will approach this guy, right? It's easy and good. Okay. So what But the problem is, okay, we want to say how good is this guess? How good is this? Good or bad? Okay. The way to do is look at the sample values. Okay? Because I want to look at, say, this guy, right? Depends on what you draw, right? If you draw this, right, at the end we will look like this. If you still recall the, so this is a random variable because this will depend on what you draw. Okay? So that means that this will be according to central limit theorem, you will get that. Okay? With the center actually is mu. Okay. And then the variance actually is called SE. Okay? SE of X bar. The question is how we can find this guy. Okay? And if you recall your undergraduate study, how to guess this guy would be the standard deviation of this one will be just simply standard deviation of data over root n. All right. There's a proof of that. I'm not going to prove it, but this is one of the proofs. Okay. And the reason not why I don't want to talk about it because we are not in that class. So this is we just need to know this. And the Python gives you the answer already, right? It's the SEM function, right? Give you this directly is over there, right? And this is what you learn undergrad. If you forget, this is hopefully you can remember right now. No, but the question would be this only work for sample mean, right? What happens if you have any other thing related? This thing cannot be calculated easily. In general, there's no easy formula for the standard error, right? The standard deviation of polygon acid. Usually you can derive many explicit formula. So the way to do, which we will do, okay, is remember how we construct this guy. Is you have many samples, right? And theory there are many mean, right? And we draw the bar chart for this guy, right? But this is from a theory, right? We don't really actually need to have this because we can't, right? So how can we solve this problem with computer, right? Although we can't observe parallel universe, but we can use computer to generate parallel universe for us. So actually, that's what we do is called bootstrapping or resampling. We'll cover soon. Is use the data, okay? Use computer to reconstruct this purple circle, reconstruct this dark red circle. We reconstruct many samples, and we calculate different sample mean, and we give this guy, right? Then we can actually calculate the variance of this guy because standard error. Okay. So one way is to use math, make some assumption, then work this. Okay. This only work for sample mean, okay. But and only if you work if the data is a nice one. Okay. If the data is not representative, not random sample, everything fails. There are many reasons why this fails. So in that case, you have to rely on computer, what we call resampling or bootstrapping, to reconstruct many possible and then calculate the standard deviation. Okay, don't worry, just give you the highlights, then we will go back to the slide and we'll go more easily. So that would be the so either you full theory or you debate. Okay? But the theory have to make a lot of assumptions to make it work. And only work for limited number of things you want to study. Okay. So in general case, that's what I said, right? The standard deviation over root n is the standard. And one thing, if you still remember, probably you may or may not, if x is either 0 or 1, we call binary data, right? You just write yes or no. Then the standard error are actually even simpler because this standard deviation is just x times 1 minus proportional data. So that would be, we used to show you that's the case. Okay. So consider case we have this one. Okay. I have a data and I use size py, and this is my data. I can calculate standard deviation. Okay. And the reason that I said we don't have to worry about the data, because the data with the Python already automatically have standard error of mean. Then we'll give you the answer directly. Okay. So suppose the data 1, 2, 3, 4, 5. Okay. This is maybe the usage data for the website, for example, how much they spend. Right. Then what you would do, right, would be this last time we have done that, right? We've done up to here. Okay. And the question is how to use this guy, right? So you will come up with the idea like the left, right, will be the maybe I do this one first, right? The mean will be the NT mean of the data. Okay. This will be our point estimate, best estimate there, right? And then maybe just make the code easier. The error will be this guy, right? Maybe I just use SE. Okay. My SE is like this. Okay. Left with the mean minus 2 times SE. Okay. The right hand side will be the mean plus 2 times SE. Okay. Then now I want to get all this number out. Then you will see what I'm doing. Okay. So this is the code that I should have added to the data. But so you will see the mean is 3. Okay. And the SC is 0.7. Okay. Okay. That is the sample mean exactly 3. The variation of this, right? The standard deviation of the bell curve will give you 0.7. Okay. And you want to calculate the lower bound 1.5, upper bound is 4.4. Okay. So your best guess is 3. But your lower bound is 1.5, upper bound is 4. So that will be given interval estimate, right? So this is same as when you look at the financial news, right? There's a financial expert will be asked, okay, what will be your guess for today's stock price or stock index, right? Say next week, what you guess the A shares composite, right? So maybe the expert will say, okay, 2,500, right? But that is not enough, right? So usually we would ask the range, right? We may say maybe between 2,000 and 3,000, right? It's a big range, but sometimes maybe we narrow it down, maybe from 2,200 to 2,400, right? You could interval. The smaller interval, the better, right? But of course, how big and how small this interval depend on how we reach our data, right? If historical data is very, very volatile, then your SE, the standard error, will be bigger, right? Then it means that this guy will be bigger as well, right? So basically, you will need the mean of the sample, right? It's your guess, right? And this will be the two number of the range that the guess will be in. And probably ask why we care about sample mean, right? And the question would be when you learn for the rest of the course, right? Which will tell you regression model, machine learning model, they are all the mean parameter of the model. Right? Later we talk about more. But we are not just interested in particular model you estimate, but you also want to care about what are the values that we can believe, how precise is your model is. Right? So that will be something that we will be working on as well. But I hope this give you some idea what we are working on. Okay. Now, this is the stock price data. We said 0.5% is the day that we have more than 5% loss, right? Because now we count the day by 0, 1, that's binary data. So that's why we can use the formula directly. Okay, is 1 over n x times minus x, right? It's 5% minus multiplied by 5%, can come up with 14%. And then you can add a minus 2 times this standard error to give you this estimate. Right? So it's 0.2% and 0.7%. That has this risk. Okay, I don't know high or low, but this is the risk you can imagine. So we have 95% saying that this is a standard way to express your interval estimate. Okay. So now, as we said, right, this is as good as if you can come up with the formula. In general, standard error has no formula. Or very difficult to calculate. Or if you don't think your data is a random sample, then this is not a good guess. So it's not normal, so it doesn't have behavior this way. So the other way we do, okay, is let the computer generate many histories. And we calculate for each history, you calculate how many days that have more than 5% loss, and you average them out, then can generate SE for us. Okay. So let's see. Okay. So there are two ways to do it. Okay. One is called SE by resampling, which we do before the break. And after the break, we will do the other one. It's called SE by bootstrapping. Okay. And they are all very super. Okay. So basically what we do is we have one data set only, but we generate many data sets. Okay. And for each data set, we apply the method we use. Right. But after that, then actually means that we have variation over all possible cases, right? Because say sample mean, you have one universe, you calculate one sample mean, and you generate many universe, which meant your sample mean for each universe generate. Look at how variation across different universe for your sample mean can tell us how accurate your sample mean is. So that's the idea. Okay. So let's see the Python code that you actually is very simple. So let's look at the sample code, then the Python code, then you will find it very simple. But let's have the conclusion first. So what we do is, okay, resampling is not to reconstruct the whole thing. It's just like out of 2,500 days, we only take 1,000 days without replacement. So we just close the eye, look at history 2,500 days. Then we just, okay, whatever we take, close the eye to take 1,000 days without replacement. And you count how many days, then more than 5%, right, for each sample. And then means that you can calculate the proportion, right, the proportion for one history, and second one up to 1,000. Okay. Then you have all these 1,000 proportion, you can calculate the standard deviation. And that would be the standard error. And then you can times 2, and then you see the variation. So let us actually implement this in Python. Okay. And you probably ask if this is so good, okay, why are we still learning this guy? Okay. And I want to say is you're lucky, because when I was a student like you, this is feasible for me. Computer generate thousands data. It's not possible without the computer power. So that's why the education is still lagging behind. But I think these days, when you go to, I don't know whether in China, but at least in the top schools in the US, the undergraduate study, they actually talk a lot about this kind of simulation generated statistical analysis. Okay? Because this kind of thing is not possible using old computers. Of course, now using your computer is so quick, 1 second, right? But in the old days, this is very costly. So, but anyway, let's look at the code. I simplified a little bit if you use the old version of slide, but it will say because the old version I used to I define a function, but now I just figure out that some of you may not be happy with define function, so just forget about function. I just do the loop directly. So what I do is very simple. I define num_p as n, no problem. I have a parameter we call n number of samples because I generate 10,000 samples there. And in this time, I got 1,000 observations. Okay. And here, probably you will notice if you learn computer science, probably you do the IT manager, right? You have the random seed because make sure that each time you generate the same thing. Okay. And the example is a empty list, which I will append things later. But this is going to collect the data, right? Because remember the key is for every sample, I have to calculate the number of days at 5% loss, and I record the proportion. So this will be record for every 10,000. For each sample, I have to record that one. So now I would run a for loop. So I think the first time we do some programming. So we had a for loop. Okay. The for loop, the loop in what we do is looping over 1,000 times. Okay. We run another some time, and we have a underscore. I think this is a special syntax for Python because you're not using the counter. So just underscore, which is like if you don't like the counter, you can use I, whatever number you want, but doesn't change anything. You repeat this 1,000 times. Okay. Each time what you're going to do is we'll invoke MP random choice, which means that we close our eyes, look at our return data, we choose 1,000 observations each time, and we do it without replacement, means that we close our eyes and choose 1,000 data and take it out. Is that correct? Then let me repeat the cookies. I close my eye, look at the return data. This number, I take 1,000 data each time. Okay. And this, I saw it as a sample at the moment. Okay. And then here I have a little bit more compact code here, but shouldn't be too difficult. So let's run this step by step. Okay. The same as before, right? I look at sample data, which is 1,000 days of this return. I look at it, it's less than 5% or not. Okay. And then I sum means I count this total number of days, right? That has less than loss at less than 5%. And I divide it by number of observation, which is 1,000 days, is proportion. I multiply 100, change the percentage. And after I do this, I append this to the list, which means that every time I create a quick history of the price, return, and then I do this calculation, I just store the final. So this will be a 10,000 number, and each number represents the proportion of days that have lost more than 5%. Okay. And at the end, the next one will be very simple. Right? So the mean will be the thing we have. Right? And the SC will be the, as we said, is the standard deviation of the data we generate. Okay. And the left and the right will be the interval we guess, right? So that is our guess will be 5.1, and then the lower bound will be 0.1, the upper bound will be 1. Okay, let's run this code, and then we have a break. So let's run this together, and then we'll see if you have any question. So let's repeat is you are having a 10,000 sample, and each sample you have 10,000 days. You have the random seed because you can put any number there just to make sure that you, every time you repeat will be the same. Otherwise, the computer will use the some random process, depending on day and the week to get it. And then I start with the resample is nothing. So once you did, you can check out what do we have there, right? So you can look at the resample. Okay, the bunch of number, 1,000 number. Okay. If you want, actually, you can plot a histogram, which I should have done it as well. So you can run the histogram. Oh, there's too many numbers to display. Let me don't display it. Rather, I should maybe I should do the I should do a bar chart, right? I should do a histogram. (0.1). So that would be the data we generate. It's the percentage. Should be percentage days more than 5% loss. Okay. So that would be what you get, right? So you get a bunch of stuff, and probably you also want to make it, it's like this. Okay. Is that okay? So that would be the percentage of the look at data. And now what we need is to go back to here and check the answer, right? This is the fun. At the end, we only care about this guy, right? And we want to export this mean, SU, left and right, right? So calculate this, right? You will see that the mean, as we have seen, is 5% of data that's more than 5% loss, right? And then the SC will be 0.17%, and 0.168 is lower bound, 0.866 is upper bound, right? So even if you are so pessimistic, right, the worst case scenario, 95%, you would say only 8.66% of the data you have lost, right? So it's still less than 1%. So it's relatively safe. I mean, I would say, of course, in the US stock market, right? If the China stock market, I don't know, can be much higher. You can have fun with that if you want. You can calculate that, right? Because I'm pretty sure China stock market, you use the standard formula doesn't apply because it's not following normal, right? So it doesn't really work that well. So you should use the bootstrapping or the resampling as the way to do it. Okay. Of course, here you can play around with this number, right? 1,000 and or 10,000, right? And as you will see, because later you will see, because we do sampling without replacement, if you increase this guy, then you get a more smaller band. So suppose I change it to 2,000. You will see that the answer we got will be more concentrated. Okay, so that's why you have to see it's more concentrated, and you will see the bandwidth getting smaller, right? It's 0.7, 0.4 to 0.6. Okay? So then the question would be, okay, how should we decide this guy, right? How do we decide this number of observation? Usually people would use 30 to 40% of the data, right? Because your data is 2,000 days, so maybe 500 or 700 may be a better, because this basically taking almost everything. So that's why maybe 500 or 700 would be a better measurement, right? And then become like this. Okay. Okay, I hope it makes sense right now. Okay, so that would be our first way to use computer to generate the common interval, right? I guess you learned it in undergrad how to do some formula, but I'm not sure you have learned that to use computer generate. As far as I recall, I didn't learn this until I go to grad school, because this is belong to the grad school idea. But now these days computers so easy, so I don't know, maybe you're learning. Okay. So after the break, we'll introduce the other one we call bootstrapping, okay, which is very similar, but we will do with replacement. Okay, but we will learn some more technique there, but that will be the same, almost the same code. Just change here, change 2 points, then you generate something similar. But then after that, then we will consider the next chapter. So I guess it's time for a break, and then you can let me know whether I'm too fast or too slow. You reply. Okay. So let's have a break of 15 minutes. We'll resume at 10:32. I'll go around to see if you have any question. And, let's see. So far, if you can remember it, I can't remember. I can remember.你们学过这个？玩的时候没学过，教玩的没用。我教我们本科就是教到这个，我刚才说的这个数学这个是怎么 S over 没有。这个有学会教快一点，我们懂的学教会一点。我先没学过就可以 simulation。因为 replacement 的话，就是比如说几个东西几个东西 replacement 的话，我就是拿完这个拿一个，拿两个，我就不可以同时拿它两次。你拿这个没有，后面不需要这个拿1万次，但是每一次就拿1000个，和目前不为1万次。你可以这个越大的话就越好，就是看电脑的。这个东西有不能太多要求。越太多的话，基本上就交2000个样本。美国都拿完了，就跟原来没兴趣。因为闭着眼睛不能再拿完，就不能再拿了。比如说你拿2500个，就一样，没有什么区别，没其他的朋友。这个样本库是你原来这个数据，本来我们数据就是一个 stock analysis， 我们这个本来是一个 stock analysis， 这个好，要么就闭上眼睛，会拿1000个，比如说1000个，拿完就不能再拿完就收拾了，拿完就闭上眼睛。2500，都摆10年，11年的，大概11年的数据，你可以拿1年或拿2年的，这个综合的 就是。对对，可以是一样，头发上一样，不一样，就基本大概率不一样。如果你要拿你这个不需要的时候，大概有讲到就是你在苦业来说关系，你就把 base，它是一个冲动的。比如说你这里有多手痛，一个东西，活动部位嘛，你就闭上眼睛随便点，对吧？如果你不是等，它就还有点混合。但是你上坡你考虑不提拉上，可以闭上眼睛马上拿出来，但是不过对。而且它，因为它的目的就在于看看你的数据是不是多不均匀、多离散、多离散。如果数据很离散的话，就代表这个估计就不准，所以这个区间的这个计算期间的变大了。因为主要我们现在市场给个计性的区间，给这个就是你的估计有那个点估计有多少，所以给一个区间估计。你学过点估计吗？就是那有的东西的时候，你不点，比如说你说他会，比如说你估计对不对？估计那个明天那个下周那个 A 盘开 A 股开了，你估计多少点对吧？2500，那估个点的话就点了，就点估计了。但是你很多时候呢，不想点估计，想那个高作者根据数据，比如说你组2400到2600，那么那个区间就这个区间估计。而且我们那种办法的这个区间估计，就是刚才说的，取决于你对这个数据的本身有多离散，可以给我们一个区间的多大。所以我们这个就是怎么去给一个区间的，就是说我就是模拟这个那个历史再重复一遍，就是看出每一个情况有多大的差异，就可以加改钱。不好意思，这个有些学过这个太平的，然后现在没学过这个，所以我也记得取个比较中间的点。你不明白可以再问。对，不用的，就在这个他问他不对的，这个 AI 帮我减轻了很多负担。不明白这个也还是基本什么这个都还可以。 没有问题，可以吗？还好，有问题的问题，可不可以开简单？我有担心这个，开简单。结果很简单，有些没什么做过。是能本科就学的，就是这边学的一个就是哎，真是的，所以你们的每个人都不一样，都比较难教。有些人觉得这个太简单，有些人觉得太难，所以我都好难调。看着我就还会发现，我上写作教完之后，我就把它调了一下，好像调一下好像调一下等太简单。我不能再调我的老师了。你们今年的水平好像比去年好，说稍微比较难一点。应该差一点好，就转越来越难。我们其他课的会越来越难，但是我们的实力越来越提高，就我要来上一年。去年我没怎么讲痛苦，去年是哪？今年就是在哪？那 case 哦，就他在思绪，好给他做不用做，又要单独，就我觉得他们都懂了，所以我今年差不多就扣一点，一些确保大家不懂扣一点，学完之后什么扣，放好什么扣。今年我就强迫大家必须要把这个空考进去。往中快一点，希望找快一点的人大家可以来。先学东西，一点的来。现在到了学习差不多很大的，关键其实上。也说。概念是大概是概念，没有怎么样，这样子的话，好，看一下按照好，后面小要什么？过去，对，前面。但是不知道，因为昨天来也是群的，然后来包括人，这个到到这里到18年，好，现在到。 So let's see how you feel, because I talked to some of you in the break. Some said it's too easy, some said there's some challenging part. So let's see overall how it looks like, because as you can see, right, I asked some of you that I do a point estimate, right? So I have to actually get the data to see how well we are feeling right now. Oh, I see sleepy. Okay, so far it's okay. Oh, so okay, I think this is a good example now. Suppose your data, okay, like this. Okay, you ask people what is the data, or some other question, and you figure out the majority of people are here, and some are here. So what we're going to do? What is your take? So the question is, do you think this outlier and drop it or not? You want to include this data in your sample or not? Because that is, remember the first class we learned garbage in, garbage out. The question is whether you include this or not. Will you include or not? If yes, why? If not, why? Okay. So some say no. Some say not the heck, but okay. So I mean there's no hard and fast rule unless you know that guy is normal or what. But people using data, okay. Usually if you are large data set, okay, and always there will be some outlier. Either your machine has some issue there, or someone typed wrongly, there's some input error, right? I'm pretty sure everyone knows Friday, but maybe there's some problem at the end and then put it on Thursday, right? But the fact that you have this, then how we will do it. And there's a rule usually people would call 5% rule again. It's called 5% means arising, or 3% means arising, or 1% means arising. Which means that if the data is like the top 5% or bottom 5% drop out. Okay? So this is so different from the rest, and it's only 2%, so just ignore it. Right? So just we ignore when it's continuing. Right? So just like doesn't exist, this guy. So whatever. It's just drop it. Conscious NA. So this is how you handle the data. Okay, I hope this is the way that understand. It's like usually we drop top 5% and bottom 5%. Right? So in our data, actually this is a good explanation as well. Is look at the stock data, okay, and if you look at the distribution, and you see that more than 10% over here, and this less than 10%. Okay, and usually when the data is like this, you would drop this outlier and you calculate everything, because especially the mean actually will be affected when calculating the average. So that's usually we drop the top 5% and bottom 5%. And if you don't have 5% and 1%, so okay. But that would be something that it would do. There's some no hard and fast rule, but sometimes 1%, 3%, 5%, or even 10%. And then you do calculation. And probably you would, once you drop it, you plot a graph and see is it nice, and then it's nice and you can continue. Okay. And of course, there's a trade-off here. Have to be careful. One care here is this may be a very observation. If you drop it, then probably you would actually remove anything important, right? And especially when you talk about losses, you cover the risk. If you drop this big losses, probably may not be good. So I have to be very careful what you want to study, right? If you want to study how likely the loss in financial crisis, right? Then you drop this, probably is not good, right? But if you want to calculate the normal day return or half the normal day risk, then you're okay to drop it. Okay? It really depends on purpose. Okay? You don't really drop it, right, when this is not the case. Right? Say suppose you want to assess the risk of going to, say, Middle East or going to somewhere war zone, right? You cannot drop really the worst case scenario. Right? You can't really just ignore it. Okay. Oh, sorry, I go back to the here. So now for this one, say for example, look at data like this. Okay. That's nothing you can drop, right? Because although the rating it seems to be off, but probably you can't really say, right? Because it's not too extreme, but you may still drop it if you like, but this one, 11% can't really drop, right? But that would be some idea that you can think what you can drop, what you can. Yeah. Yes, standard deviation. So standard error is the main thing you want to look at, right? Because either you can put a formula or can do resampling idea there. Okay. More practice, yes. So that's the reason why assignment 1 is asking you to reproduce not all, but many of the Python code we learned in class. Okay. We give you detailed instruction how to write the code. Probably we're using the hotel data again. Then I can ask you to download data and combine data, filter data, and draw a histogram and do all the calculations we want to do. Okay, so that will make you do practice though. So don't worry. Oversample, yes. So I think everyone got the main idea because usually a point estimate that's easy, right? But the interval estimate is much more important, and this will be important when we estimate model. Right? Because we want to know how good the model is, not just the mean. But later you will see, so don't worry about that. Okay, the speed is okay. So if I use the 5% rule, then I just conveniently say everyone is happy. Okay. Right. But now I have 11% that say cannot be easy, so I can't easily cross out that. So not everyone easily follow. So I understand. So that's oh yeah, it's getting cold. Just to remind you that you can see I have a long sleeve already. So it's cold there, especially on the Israel train, it's very cold. Because I take the Israel all the way to Hong Kong Island. So I have the jacket with me because it's so cold. It can be so cold. I mean, just be careful because now it already passed the mid-autumn, right? So it's already mid-autumn and also Chufen is already passing through the winter and the fall. So it will getting cooler and cooler. So that's why next week you should hike because before the cold come, I mean, you hike and then there's no sweat. So try to have fun around because hiking is fun. Assignment is not hard because basically you just change the code that we learned in the class a little bit. So there shouldn't be no innovation for that. Fence? Yeah, we can again. Okay, good. So let us go back to the case where we do the next one. That will be very quick. Okay. Do you know that we do the without resample, then we do it without replacement. So we close the eye and pick up the history, and that we can't take the same, suppose the stock price, we plot the same day. We pick this day, then we pick other day. Okay. But the bootstrapping is a model that actually you would be doing a replacement. Okay. And we also do each sample, okay, is same as original sample size. So what I meant is we have 2,500 days, right? And actually we create this exactly the same number of days, the data, but we allow ourselves to draw the same date, right? Otherwise you every time you got the same thing, right? So let's look at the graph again. Then maybe look at the graph. This one will be easy. Suppose the data you have is 1 up to 6, right? And you can, based on this, to calculate the sample mean, right? Which is the best guess you can have, right? Based on that. but this is not sufficient. Right? So what we're going to do is we will create parallel universe based on using computer. Right? We close the eye, pick up the balls. Do note that we allow replacement. So we can take the same ball, right? We take out the ball and put it back. Take the ball and put it back until we do the same number as here. Right? That means that we have, say, 10, 100, or 200 of this sample. And for each case, we can calculate the sample mean, right? And look at the standard deviation of this sample mean will give us how good is this original measure. So that is the main idea, right, behind what we're doing. Okay. For those who have learned it, I'm sorry, it's very simple to you. Okay. So what I do is later we do in Python. Actually, just change some line there. We are again create 10,000 samples. Okay, and each sample you also have 2,500 days. Maybe I change this name to observations better. The observations. And you can calculate mean, median, mean, max, SD, and then SC again, right? And then you can look at this is our estimate. Okay? And you may ask why I talk about this two different methods, bootstrapping and resampling. And you can imagine in the old days, right? Computer is slow. Resampling is more commonly used because you just look at some small set of the data, right? But now this day computer is so convenient, so most people will do bootstrapping. This is I think is the predominant tools. Okay. So let's look at the slide, and you do notice that the only difference I do is here. This one, okay. This red, the yellow one and this yellow one, there's two yellow ones. It's the only difference between the code I have, a few slides before, and this code now. The difference is you do 10,000 sample, and this sample you got the same as before, same as the data input, the return data out into the return, right? Got return data, and we replace it here. Okay. And after we did that, we'll show you again, but we can do the mean, max, median, medians, SD, right? Look at the plot, right? And then look at this, you can calculate all those. Okay, so let's repeat because it's so simple. Just like let's just quickly copy and paste here. I guess it shouldn't be a big thing because this is the same code, right? I just be lazy, right? Just copy. Okay, I can run that. I forgot to have a space. So once I did that, then it's done. Then I want to show the, I skip this part. I want to look at the histogram. So the histogram will tell us, okay, under the bootstrapping, right? And this is what might look like in many different universe, right? We will keep the sample them, right? So you can go as 0, right? And it can go as top as 1%. So that's how many days that you can have more than 5% loss, right? So this would be the data you have, and you want to summarize to something, right? That is actionable. Is we will do the 95% confidence interval, right? Calculate the mean of this, SD of this, and then this the left and right will be the number that we care. Okay. After this, we'll stop a little bit, and then you can go around to check whether you can follow. Okay. So that would be okay. So I'll go around. If you have any question, please ask me because we're done with the estimation. So that would be applicable for any scenario, right? Because you get something using your data, right? Then that is from the data, and you want to see how good it is then you recreate the data hypothetically many times, and you can see how good it is, right? So instead of make up some number or you do the guess, this is a good way to make guesses, right? So this will teach you the way how to use the data. Not just some number, but come up with a range of number that would tell us better how it may went. So, okay. Okay, so make sure that you are okay with the code and you can copy, can run, you understand every single line because these are the things I will ask in the assignment, right? Probably you, of course, you just change the variable you're doing, but hope that at least you understand what's going on. But I noticed that the ChatGPT or 文心一种啊，英文啊 I don't know 文心那个 AI can do a lot of job, right? So of course our TA always is helpful, so she will help you in case you are stuck somewhere. But if you have a question about the assignment, don't bring the assignment to the TA and ask how it can be done, right? You have to do something and then she can help you, right? But anyway, I don't think you need to do this stuff. It's programming exercise. So the worst case is you go to the ChatGPT or POE to ask him to help you, but you won't learn much if you just simply ask AI. But anyway, nothing can stop using AI anyway. So I hope that is okay right now. I mean, it's so a final remark for this estimation. Okay, and how good is the data? We determine how good is the conclusion. Remember, garbage in, garbage out, right? So we always have to ask ourselves whether the data is appropriate. Okay, so I probably will not do it for your assignment, but you should think about for your project, right? If you look at your data, is it the timing the right? Is it the past represent the future, right? As I mentioned, right, if you want to say in the website, looking at the weekday traffic and the weekend traffic, right? So if you want to predict, say, weekend traffic, you should use weekend data, right? Even though you're the weekday data, it's just wrong. Right? Of course, we can do more when you have regression, but if you simply doing what we're doing right now, I mean, you have to make sure that your data is consistent and share the similar characteristic with what we're predict. Right? That will be something that have to be careful. And also the geographical spacing, right? Suppose your data from Shanghai, right? Is it applied to Beijing, right? Is it going to apply to Shenzhen? Is it going to apply to, say, India, right? Or Indonesia, or Europe, right? So this has to be a problem whether things can generalizable from one to the other, or is it going to be across group, right? Suppose this is male or female should apply, right? So that has to be something. And final remark will be when you take data, okay, turn out, perhaps not surprisingly, if you wear large sample, then your CI will be almost zero. Why? Because if you look at, just simply look at the formula here. Use method. If you use this, okay? If n is 1 million or 1 billion, okay, this is zero. No matter how big this guy is, unless this is super big, usually this is controllable. And this goes to very big then. There's no difference between the CI and your point estimate, right? Then you would be very tempting to conclude that you have very accurate data, right? But in fact, you are not, right? Because then you have to be, that's why you can't use the classical method when you have using a big data set, right? instead you should use the resampling or bootstrapping, right? And you will see why we have two different type of stuff, right? When your N is big, right? You use big data. Bootstrapping is not possible, right? Suppose you have 10 million observation, right? You create 10 million of this, it will be computationally costly. You can't really do this, right? Then what you were doing is not bootstrapping, rather you do resampling, right? So that's why, although bootstrapping is still very commonly used for most of application, but when you have big data, this really doesn't work, right? You can't really create a 1 million observation, right? So you have to go back to this resampling idea, right? What do 1,000 what's much smaller manageable data size. Okay, so big data has to be something slightly little bit challenging, but because we don't have time to go over that, but we do have tools that help you to handle those cases. I mean, I told some of you, right? And then next semester, many of you are taking the AI class or the machine learning class, right? So this is the preparation for that. Okay, is that okay? So I will skip the technical part because if you understand this from undergrad, it's all undergrad thing, then if you recall it, it's good, but if not, then it's still okay. I just skip, sorry, because of the time. And we are not asking for a technical slide or your assignment or your exam. Okay. So make sure that the main thing is for this class is to understand the Python code and the reason behind the videos, right? Because this is the main thing that I want you to bring with you after this class, right? It's very likely that you will forget most of the stuff. Unfortunate fact, but you have a slide, then you know the Python code associated with that, then easily can take it up, right? If someone asks you how you run the regression, how you estimate this, you can quickly pick up the code and then just go back. This is my hope. I mean, obviously, no one will remember everything, right? Because our brain is very limited. So the good thing is you try the Python, your muscle memory, you type the code, right? Don't copy. But even the copy, you just type out the code, then you will remember in some sense, right? Hopefully, our assignment one, you just type, don't copy from others, right? Even though you copy, try to type it out. Okay? About testing, okay? And possibly you would, it's a natural topic when you that is after learn estimation, you do learn hypothesis or you one way or the other. Okay? So what hypothesis testing is about? Basically, it's about using the data, okay, to test a statement. Okay? So it's a little bit abstract. So the idea may be say, we have some idea about say how risky the stock market is, right? Like the 5% loss. We learn the case study, okay? And then we try to see if the data is supporting this statement. Okay? So you want to say whether you reject it or you don't, right? Because we have no hypothesis, right? We know something, okay? Or we have some idea what it might be, and then we want to say what data is supporting or not. Okay? So this seems like if this is what you learn in the undergrad, I hope, right? I think it's right? But you see why this related, right? This is so technical, right? Why we have to learn all this thing in our class, right? Because at the end of the day, we are after this class, we learn regression, we learn machine learning model, what kinds of model, right? Why we care about hypothesis? Why we have to have a statement about say population mean? Why we care about this? Right? Why we have a statement about whether two samples are same mean or not? Why we care about that? Okay. The question is very simple. Let me draw a diagram to convince you this is something that is very important. Allow me to draw some kindergarten picture to convince you this case. Okay. So remember this diagram. Okay. This diagram is I use this X bar to estimate mean, right? And what we do is basically using the sample characteristic to do a guess, right? But usually this is not what we want to do, right? What we want to do actually for the rest of the semester is the following, right? Okay, each is more complicated, right? Each observation, okay, each observation you have has, say, many features, many characteristics, many dimensions. Say, for semester, I focus on 2. So there's dimension X and dimension Y. Okay, maybe for IP application, maybe how much time you spend on your website, and then how much purchase you do in your website. Or of course, X can be many things, right? Many characteristics. The question is, I want a model to relate X and Y. Okay, X can be many things, but that will be the second. I want you to have an idea that how X will do Y, right? And of course, the data will tell us that it's very complicated relation. But we want to simplify the relationship into something very simple, right? If you learn regression, what we do in regression is what? If you remember, when you learn in the in the undergrad, right? It's like this, right? The scatter plot, X and Y, bunch of point here, right? And then what we learn is regression is to draw a line there. Line, not here. It's line here, right? The best line to fit it is regression, right? The median. Of course, we can imagine 3 dimensions, right? X, Z, and Y in all 3 plane. Of course, more than 3 hyperplane, but basically just find a line to summarize this relation, right? Because it's a dot, right? But we want to say, okay, in general, how X will work, right? We only have finite number of dots, but you want to say this would hold for every X, right? So the question is, if you align, okay, why a line so complicated can simplify our understanding? It's because a line, if you learn from the high school math, which I think you do, right, is the slope, beta, and intercept alpha, right? A line can be easily represented by 2 numbers, alpha and beta, right? Alpha is intercept. When X equals 0, what is alpha? And beta means increase X by 1, how much Y will increase, right? And you try to use the data to come up with 2 numbers. That is estimation. And you want to also come up with confidence interval. That's what we learned just before the break. Now, why we need to learn the hypothesis test? It's because we want to make sure that this number is a valid number. It's a number that actually come out, not come from randomness of the data you draw, but rather that number that is real. The main hypothesis actually we would do for the rest of the course very often is we want to test one thing, is whether beta is 0 or not. So we want to test this null hypothesis H0. We want to test this out. Okay? We want to see our model is actually useful. It's look at the parameter we estimate is actually meaningful. And this is the rest of the class, because no matter what we do, we do regression, this is what we want to see. Right? We want to test this is the case. Okay. And of course, for machine learning, that is not feasible, but there will be some related idea there. But the classical method you have to do is this is the way. No matter what you do, this is the standard technique here. You want to say your model is useful, you want to reject this. So we have a this is null hypothesis, and this is the alternative, right? So you want to say data if this is the case or this is the case, right? Of course, we want this is wrong, then our model is useful. So that would be that. Right. So that would be the case. That is the reason why we learn this. But But I hope I convince you that what we are learning is useful. Okay. So in this case, the statistic in fact is the parameter alpha and beta. On beta, don't look at beta. But the beta is 0 or not. Okay, I hope I convince you. But this is very good, right? Because I want to see the data. Okay. Once you estimate whether the data is there. Okay. And of course, you would tend to say, okay, how do we do that? Okay. And to give you a general idea, in general, it means this estimation and hypothesis are related. Because what we want is beta, we come up with an estimate, the mean using some algorithm, some method to calculate that. But what we learn is we can construct a 95% confidence interval. Okay. And simply speaking, is if this interval doesn't contain 0, then we will reject. Okay, something like it's a little bit more convoluted, but is we are trying to see, we have to construct the interval. If the interval doesn't contain 0, then we'll safely say 0 is not there. If it contains 0, then we're not confident. So the model is correct if your interval contains 0. But we'll talk about this later. I mean, this is the main thing you learn for the after your hiking holiday. Okay? And then we'll learn this in great detail. But that would be the idea. We have to need to keep some foundation what we're doing then. But that's the main thing. Okay. So you already see the x0, x1. Right? X0 is something we want to reject. Right? Using the data to take it away, right? Then we are very happy. And then the data can be useful. Right? So basically, this is checking the validity of data. Right? Sorry, validity of the model. But the model actually is useful because you estimate data. So estimate model, you want to see the model actually is a meaningful model. You have to do that. And there are in statistics, you will see, I don't want to go over that, but just it's very simple. It's like usually there are two types of hypotheses. One is called simple, one is called composite. Simple just make a claim about a parameter equals 0 or not. Equals 0 equals a number. And composite means that it's much more complicated. Okay? It's not equal to 0, can be equal to any other number, more than or less than. Okay? So these are the things. And in our class, we always focus on the case where what we want to test is always simple, whether it equals 0 or not. Okay? And if you remember the undergrad, which is not very important, but I just put it there, it's usually we say whether it's two-sided or one-sided hypothesis. And in our class, sorry, it should be two. It should be two-sided. We always focus on the two sides. Sorry, we always focus on two-sided. Okay. Sorry for this typo there. So we focus on two-sided. And finally, I want to talk about this doing decision. And when we make decision based on data, there will be two types of error always. Okay? If look at the table, it's very simple. If this is true, you shouldn't reject it. So that do the right thing. Look at the second column. If this is false, you reject it, then it's right. Okay? The green one are right thing, right? Because when it's true, you keep it. If it's false, you reject it, that is correct. But people actually characterize two wrong way you can go. Okay? The type 1 error is true, but you reject. Okay? Even though that's right, okay, but because of you do the sampling of data, it can happen in the case that you actually got you get it rejected. Okay? become type 1 error. Okay? And if it's false, right? But you didn't reject it, then it's type 2 error. Okay. So that would be the cases. Okay. So the way that we do the hypothesis testing is to balance these two error. Okay. If you learn from undergrad, but we don't tell you how we do it. Okay. But in order to balance these two error, okay, we will use two methods. Okay. The method we use is called the critical value method. Okay. And we will calculate a test statistics when it is more than critical value, or then we will reject it. Okay. So let's see the main idea here. Okay. So let me go back to the idea of the sample mean, right? Remember this guy, okay? And we want to use this to measure this guy, right? Now, what is the main idea to do hypothesis testing, right? So suppose the hypothesis is mu is equal to 0 and mu not equal to 0. Okay, so that would be something we want to do, right? Or just want to check, right? And if you recall, okay, this under central limit theorem, the bell curve, it's a bell curve here. Now, how do we operationalize this hypothesis testing? Is first, you assume this is true. Okay? You assume this is true. Okay? Assume this is true, and see whether data tells us the same story or not. So assume this is true. Okay. And true means this is 0, right? Because it's here. Okay. That means that you would likely to observe the sample is around 0 most of the time. Okay. That means that if your data is here or far away enough from 0, then this can't be true, right? You say your probability mean is 0. Okay. If your sample mean is actually close to 0, you don't have anything to say. But if your sample mean is actually very large or very small, then you would say, I don't like this one, I like this one. Right? So how do you define is large enough and small enough? Okay. And in statistics, the general rule is very simple. You would say you allow 95%, we will call close. Okay. And both sides remaining 2.5%, this is called small. Okay. If it is the area is like 2.5% on both sides, we define this is called the critical value or critical area. Right? This is critical. This is a critical value. Okay. These are two critical values. Such that if the data is more extreme than these two values, then you declare that you would take this out. Right? I mean, this is I think you learn in the undergrad, but just a gentle reminding. Right? But you do notice that this is very close to confidence interval, right? Because this is indeed, if you remember, this, right, is indeed 2SE, right? If you it's 2SE, true standard error. So, or you can imagine, where is your data? If your data is here, you go to the error with input 0. So that is the reason that I said, right? You construct the data, you construct confidence interval with input 0. Same as you go from 0, you construct the standard error in this way. Okay. So actually that explains why the true standard error is the key, and hypothesis testing is actually not different from estimation in most of the cases. I mean, there are some cases that are some different, but in general, that's it. At least for the case we studied. Is that okay? I think you learned it in your undergrad, right? But just a very gentle reminder, actually, what we're doing. Is that okay? I mean, of course, I just talk a little bit about background because I noticed that finally, this is the last terminology. I'm sorry, this final terminology is called p-value. P-value is closely to the 5% idea. Okay, so it's very simple. So what we have is, remember, this is X bar, and this is the 0 here, right? Because H now is 0. So we said that there is a 95% within this two, then we will be happy, right? We will say we don't reject, otherwise we reject, right? So this is, we have a 95% 5% rule, right? Is if this is here, then we don't, right? So the p-value is what? P-value is related to this is if it, instead of looking at these two critical value, okay, the p-value method is the following. You look at your data, right? You actually got one data, right? You calculate the sample mean, right? This your data, complement data. Okay, that's one number. It can be somewhere here, say it's here. Okay. Of course, we know that in this case you will reject an hour, right? But these days people are not just interested in reject or not reject, right? People actually care about the p-value, which means that what is this area? Okay, p-value is defined as this area times 2 is the p-value. Okay, you ask me why, but let's keep it simple. This is, we don't know technical definition, but this defined p-value. And there's some technical definition what's p-value, but in our case, it's just 2 times this area. And you, on the right-hand side, is this left value. If you end up in the left-hand side, will be this area times 2. Okay, and the reason why times 2 is before you do it, you don't know where it can be. So this times 2 to make it work. The definition is the smallest selection level that make you become reject, but I don't want to go to the formal definition. And of course, the smaller the p-value, right, the more likely to reject this guy. If p-value is 5%, just reject, right? If p-value is more than 5, right? So that would be the active, right? The p-value, okay, loosely speaking, you can say how likely that you figure out that your data, okay, is a where scenario, right? That means that if p-value is small, then you want to reject, right? Because if it's true, something comes out is where you have low p-value, p-probability, right? Low probability, right? Then you don't really think that this is appropriate, right? If you're a center, your p-value is very high, right? So you don't want to reject. And notice that this is a little bit more philosophical. So don't worry, you just go to the data application, then you will find it much more acceptable because I can see that your head explode when you go to little bit math. So we'll only focus on one simple case as illustration. Okay. As we have done, assume the population follow normal, okay, and everything is random sample, and the sample mean follow the student T. Okay. I mean, this is what we learned, right? 学生分布, T 分布, if you recall your undergrad, right? This is something you learn. Okay. So we focus on two specific cases. I hope this is enough to remind you. So we want to test one thing, right? Whether this equal to particular A, and usually A is 0, as we shall see, right? A belongs to 0. So math will tell us how we do that is you will subtract this A over the SC of X bar. If you recall, this is standard deviation over root n, right? And this follows the student T distribution. And then the good thing is look like this. Okay. The critical value are just 2 when you normalize it. Okay. This, when you calculate this, okay, this value, you just need to check whether it's more than 2 or less than 2. Of course, those of you who learn stat enough, then you say it's wrong, but because we just do freedom. But the thing is, like, the data you have is at least more than 200, and there's no difference between standard T and the normal. So what you're going to do is you do this calculation, right? Take this over this, and you compare to 2 or more than 2 or less than -2. Okay, and if this 95% in the middle, right? If you reject on the both ends. And we don't do type 2 error, it's very complicated. Okay. And we also have another test, it's called the 2-sample t-test. But the easiest is to just the difference. Okay. And then you also do the calculation, that shouldn't be an issue here. Okay. But don't worry. What we're going to do is rely on computer to give you the p-value, and then look at the p-value, then you're done. Okay. So look at this example. After that, we'll break. So we have a package num-p, right? I think it's well known by now. The second line is a size iPhone we're using a set. Okay. And now the data is 5789. Okay. And we want to see is the mean. Okay. We have say H now. So the question is here is want to test in this example is we're going to see whether H now, so mu is equal to 7 or mu not equal to 7. Okay. And of course, even without doing this, you know, you can't reject H now. Why? Because look at this data, the mean is exactly 7. Right? So you want to the data is 7, so we can't really say it's not 7, right? So you would what you do is usually t-test one sample and now, okay. Then you can do the t-test. Okay. So let me copy it. So I think we have chapter 6 here. Right. So if we try to run this guy, okay, you will tell you that, of course, what you care is the p-value, right? The p-value is 1, so you can't really reject, right? But now let's have a fun, change it to 2. Okay. Then we want to see whether you reject or not, right? Because the data is way above 2. Okay? And let's see if we have enough evidence to reject this one. The answer is okay. Is the p-value is less than 0.5, so you reject, right? But if you change it to 3, say suppose, let's see you will reject or not. So for 3, still reject. What about 4? 4, then you still reject. What about 5? 5 is almost reject, right? But for 6, we don't. Okay? You really can't say it's not 6. Okay? But you can easily see that I just need to look at the p-value. Then I can make a decision whether the data supporting hypothesis like this. Okay? And as I tell you, this is going to be useful when you look at regression. Right? You want to see later, I want to check your regression coefficients of the parameter model is 0 or not. That will be key part of the analysis. Okay. So as I said, let's have a 15 minutes break. Then we come back and then we will end the rest of the chapter. So let's resume at 11:40. Okay. Maybe I should open the U reply in case you have something to ask. I don't know, is this too we do is too technical or not? 慢一点点。小的是团体大的时候，边后来那边我，让我出来，我开完了，然后啊，这边是后期很长，这是看大的。考试技术以来，就就是看讲座，因为我不喜欢背东西嘛，就是一个对，一个不喜他人，本来是业绩提方面的东西，虽然后来说等到换了我背景的是有变过来是那个后续的前一天和大家对啊，就是还有钱，因为他们首先派的每路一个后边第二单的这个问题的话，别人这个太一个上来受人教你多的话，就教你这个基础的，我最难的是你结一个完全没有学过的话，就后面而且你有一本定的说啊，对我基本上上的说点基本都是给一点点基础的，弄赛很难。有一点点100%就是第二个，还有那些最好给剩下的东西快剩的，但是你给他一部分东西，对，你要明确的方案，而且你基础有一点，有那个还有他给对吧？谁有文章，谁把那跟别人谁都改一个就给他们打出来，你方案他第二个嘛。对，但是你有公司在那些，我都是看到。对，在他们。但是还好，那个我说到那个，我们来看。对，所以我会很好的我就不谈，说对，你讲的细节，我之前那个你看看，有雇主安排都是没有什么，不行。把炒菜这个没跑的，那以前吃饭吃不上的，可能那个现在吃饱饭。 就是比较技术化，就是生产力足够大的话，基本上会做没有人它足够大。那中东的国家会引起他们是对原创，所以电脑是一个人工智能是一个大概这方面，所以在做其他一些。出席的时候，我们是最终在学，我就在读书的，其实你们在做，我在读，所以我还是有的。对啊，那你才能看。对，你显示的话是一个自动化的地方，现在也知道了。以前不换，现在哪里开始？我就把我的学习，他在有看我给出来。所以没想法，就是我也知道，我必须看出来，是不可以看电脑。但是你还可以用电脑我是可以。我这个买手里面，我这个拿手里看，对，我就看我这个看我的同事跟干的大概少了他们的我认为是在这个，你必须要还是这个东西。对，我这个搞一大学生吃不了，所以没有这个小科研这个啊，没有这个还是受不了。那个想想，现在我现在是小孩子一样的，我当时12就没了。时代不一样的，我就老师以前会很高，也会消失。很遗憾的是，So let's see. Hopefully you don't have any problem, but I guess if you forget the Hubble testing, then I think we're going a little bit fast, but otherwise should be okay.
Yeah, type an error. Okay. Speak is okay, I guess. Okay, overall it's okay. Okay, so far so good. So I'm sorry that I mean we can't really go into very deep detail for the hypothesis testing because of the time. But if you have two samples, okay, which we will do soon, is to have two set of data and see whether they're different. And you will have called the test independent. There are many ways, but I use this one because of, I don't want to bother you with that. Imagine that the two sets are independent, and you use a test and whether they're same or not. Okay? And so this is exactly this guy. But depend on what kind of assumption here, this will be different. If you're undergrad, there will be there many ways to estimate this guy. But we are not going to go about that. If you want, I can send you some undergrad slides, which I teach these days. Can give you more, but we just need the one of the simplest one, assume the independent. Okay. So why we are doing this is because we want to look at this example. Okay. Is whether we have a project that's about billion price project that also collect many offline online prices. Okay. So you want to look at whether these online price and offline price are different or not. Okay. So that would okay. So that the question is look at the different, right? You want to test the hypothesis that whether the DIFF is zero or not. Right. So that is actually all the time we also often company use this. The reason is okay, if they're the same, then we can focus on online classes. Right. You don't have to focus, we don't need to separate the two things. Right. This is often commonly do before you do data analysis, right? Because suppose you have data for male and female, right? And then you discover that there's no difference between male and female, then you can combine data, right? Then you can don't need to take care of the characteristic difference. So that is usually they done in this way to check they're the same or not. If they're different, then probably you require some different treatment. So that is something that we do. Okay? So let's look at this application. Okay. And what we're going to do is look at different data, the data set of the B.B.A price. Then first we will filter the data, focus on the country, USA, first, and then focus on regular price, means that we don't look at the sales, look at special price. Okay. And if there's sales online, say Thanksgiving or Easter or Christmas, then you will drop. Okay. And we only want to keep the observations that only have both online and offline price available, because otherwise we can do the difference. Okay. So, and at the end of the day, we want to test hypothesis this is zero or not, right? So that is the main goal. So we start from the beginning, clean the data, do the analysis, and see. Okay, we will start from the beginning. Okay. Again, the first two lines shouldn't surprise you into the libraries, and then the last two lines will be give us a URL and then import. Okay. And some of you may notice we have something new here is encoding. Okay. The reason why we have to include this is because the data set contains non-English character because of the worldwide data. And then if you don't do that, then you will complain. You can try. You're using without that, you can't import. So you have to include this very weird thing. If some encoding, I mean, you are IT manager, you know that it's just like how we interpret the character. You put the data, right? But for us, you just keep it for just copy it, and shouldn't be a big thing for us. Okay. So suppose I don't have the encoding, then the code will complain, I think. They will say, I don't know how to do it. It's a very complicated stuff. Okay. So you have to include this one, then they have no problem. You can see if I include this one, I tell them how to interpret data, then they are not too angry about it. Okay. And since we have that, then we can go forward, right? Now with data. Okay. Of course, as we said, we want to first focus on the case where it is a USA, right? Or it's LOC computer, right? And price is regular. I want to make sure there's no online sales. Price and online price are available. Okay? Only if these criteria satisfy, I keep them. And next, I would also want to focus on normal product. So any price more than 1,000, I just drop. Is that okay? So that is the main idea what we're doing. So you will be asking to do something similar for your assignment. Okay? You will be asking to do the filtering idea. So once we did that, we're happy with the data. So let me wait 10 seconds. When you're copying the data. I hope it's okay. Now we want to do an EDA, exploration data analysis, right? Looking at what the mean, what the max, what the n, and then how many data we have, and for a histogram, right? So this is a very standard technique, which we will do for your assignment one. You will also ask to do this. And remember, we care online price and offline price difference. So I get the difference between the two columns, okay, and call it diff. Okay, this is the difference between the prices, okay. And then once we did that, we want to look at some basic data, right? Look at the mean, look at the standard deviation, mean, max, and look at the count, right? So we know how much data we have, okay. So that would be the second step, right? So we want to look at this. So don't worry, we will all, this seems to be doing all the process again. So all the data handling. So we start from the beginning. So you can see diff, right? It's like how many you have, what's the mean, what's the SD, what is the mean, what's the max. You do notice that median is 0, 75 is 0. So it means the majority of them are 0. And this is all the way from 0. Right? So at least look at the IQR, right? In the quartile range is almost 0. Right? Look at the 75 minus 25, it's almost 0. So basically most data are 0, right? But there's a huge difference, right? Here you can see the online is more expensive. That's right. The mean is online is less expensive. If I look at the mean, right? It's like, okay, perhaps a little bit surprising is online is slightly more expensive in US. Right? Online price. So at least given the data we have, but now I guess Amazon needs to be the other way around. I mean, look at what happened in China or other world, right? All the offline store actually doesn't work very well, right? Maybe off the software or business. It's not unique to China, but in US, in other places of the world, right? So anyway, now the next thing is you want to plot the histogram. So I use one as a bandwidth. Okay, and do remind you that when so a histogram, you have to add the bandwidth for the max because the way that how Python generate the range have to be added back. Okay, just make sure that you don't miss this particular part. So when I copy this, I will draw the histogram. So these are the steps that I would ask you to do your assignment. So don't you repeat the same thing, but apply to different contexts. Okay. So you can see most of data here on 0, and then there's somewhere here, somewhere here. And if you don't like this guy, remember you can do the density true, okay, to make it a relative. Okay. But the same graph, but this you can see the percentage, right? You can see 70%, almost 70% ours. That's no different with online or offline class. But this gives you some idea, right? Because before that, it's not entirely clear. Oh, I think I got the wrong X label. It should be price. Sorry. That's it. There's a typo in the X label. The difference between the online price and offline price. Sorry for that. Okay. And let's do by hand the t-test, but we'll do Python again. Let's do by hand first. Okay. You do the t-test, you have to calculate standard error. The standard error, either you use the Python SEM or you kind of standard deviation over square root of n, but either this. Okay. 1. And then you take the difference, which is mean is at 5%, right? 5% over this, will give you 0.4. Okay. And you do remember that the cutoff point is 2. Whether it's more than 2 or -2, right? That would be more stringent than that's not. So we can't say that. Okay. Is that clear? So if you want, you can do the same thing, right? You can do the calculate the SD to the N to the SC, and then you can tease that will be this. So again, to tease that also this guy, right? Of course, probably you say, okay, well, I have to do this, okay? Because you can do this and done. One step, right? I just do one step, right? Why I have to do so much trouble, right? Because t-test actually can done in 1 second, right? As I told you. Right? P-value is like 0.66. It's not more, less than 5%, and you're done. You are gone, right? So that's fast. So that is how the statistics work. So this is single line in the bank, right? You can test whether the online price and offline prices. So I hope that convinces you that this is useful. Right? Because your IT manager, maybe you're tasked with this task, right? You have some offline price or the price of your platform or price of the other platform. I suppose you work for JD, then you want to check how Tmall is doing, right? You compare 2 different prices and you do the same, right? You will be tasked to do that, right? It's not something unknown, right? Or you want to see whether man or woman, they do differently on website. Same, right? Or people come into the day and during the afternoon are the same, right? Or this kind of question can be asked. Is that okay? So basically just a quick review what we have done today, right? The 2 main things is we do estimation. First thing is we do point estimate, and then we can extend it to interval by adding a -2 times of SE, standard error. And standard error can be done in several ways. One is by theory, which will tell you the, for the sample means very simple. It's a sample variance over root n, right? Or you can construct by computer, by simulation. You create history many, many times and create your statistics and look at how the variance of the statistics gives you that, either the bootstrapping or resampling. And The next is hypothesis testing, which is closely related to estimation, right? But the idea is we have some statement, we want to show it whether supported by data or not, right? And actually, the idea is very similar to say we construct the interval estimate, whether the estimate include in the null hypothesis, right? Basically, you can say, right, we just did that part is, right, the very last thing, right, we did is we look at the difference, right? It's 5%, right? 5 cents, right? You can also construct, based on this, construct a 95% confidence interval. And it turns out that you will include them 0. Then you also do the same conclusion there, right? So that's why they are actually you can say estimation hypothesis is basically the con but different side, right? The same con but different side. Okay. But now before we end, because I think we still have time, so I think it's good time because we have done 4 classes, right? It's 1/3 of semester already, right? You may aware, not aware, right? It's already a quarter of it. I mean, you still have no 1/3 of it, right? So you still have 2/3 of this to suffer, right? So you want to know what is ahead, right? What's ahead, and then that'll be good, right? So let's talk about what is left in our course, and we tell you that some material will skip, okay? Because of time constraint. So next week we have holiday. So the week after, okay, the week after your hiking holiday, we will actually do something real important thing is do regression as we have done joy line, right? Basically, it's at the end of the day, is we'll do a regression means like this. This is a bunch of points, as you just seen. We'll draw a line to best fit this is regression. Okay, and here just only have x and y, but in general you can have any arbitrary number, and we want to draw a best line to fit it, and that will be the way we do in this chapter. And we also learn how to draw a non-linear line because it's a linear. So how to do a non-linear line, then that will be this after our holiday break. Okay, and lesson 5. Okay, the whole lesson is about drawing a line, right? It's about, you can see, not surprisingly, how to generalize this is we have to see again confidence interval. Because we want to use the model, right? Once you understand the model, we want to use the model to do a prediction or estimation, right? Because why we care about data? Because the data, we can use it to do prediction, right? Because we want to learn x and y, how they are related, right? And then, because that is the summarize of our understanding of the world, right? And then we want to apply to practice, okay? We extend it to multiple linear regression, at least more than one, right? Because the previous chapter only x and y, right? But now we have y, x1, x2, x3, x5, x100, right? When we have big data, maybe x1000 can be a lot, right? But there's no problem. You can handle that. No matter how many, you can do it. As long as your computer runs fast enough, there's no problem. Okay, so that would be this chapter. Okay, what about the lesson 6, okay, which we'll do? Is related to this one. I'm afraid that this is the topic that we'll skip because we don't have time. Okay, but basically with about modern probabilities, why something want to explain usually can be continuous. But what happens if just yes or no? Okay. One probability. There will be some logic and profit, but we will probably skip that because of time. But it depends. If it's really good, I don't know. I'm not sure how fast we can go. And the next one is called time series analysis. It's a case where it's usually most used in financial data, or if you look at the time trend, right, where you would think, right, the past actually carries some more metrical future, right? Look at the A share now, right? What's the best guess on Monday? Up or down? Who say up? Who say down? Oh, so everyone say it's not moving. But I think the best guess is up, right? It's been up, it's a continue up, right? So the past trend is going to help us to predict the future. Next time, there will be a little bit more than that, but there will be more model than it's also regression. But regression, you have to control those kind of stuff, so slightly more complicated. But I don't think we have time to cover this. If we have time, we can do it, but probably we will skip this too interesting chapter because we want to. The reason why we want to do this is because we want to introduce prediction and more importantly, linear regression, which is the first machine learning thing. It's a simple regression, okay? And probably you would ask what's linear regression. The idea is like, so in regression, you are trying to explain y by ln x, right? And you, as human, your brain decides which x is right, right? Say, for example, you go to Shanghai People's Park. Oh, no one knows Shanghai People's Park. That is so interesting. When I teach economics, I always talk about that. Yeah. Know this one? So go there, right? You will decide what kind of man and woman you want, right? You say who you are and what, right? So now here is, I hope everyone read Chinese, right? So here, right? So he said, he's just looking for who, right? So actually you're doing regression. Why? You're asking people to have this, you have this that satisfy they would add to your mark, and why is your mark, right? They're good or not, right? So you have to pick what you care, right? The human mind, pick what you care, right? The regression is just to pick what thing that should be in your model, right? So, but the thing is, we know that there are too many variables in the world, right? Especially you are the IBM, your IT data, right? There's a huge number of columns, right? So can we do it automatically? LISO is a way that there's some way to select what kind of variable that is the best to do prediction. Okay, so instead of using the idea, right? This, right? Or this, right? You would ask a computer, ask this guy 1,000 characteristics, right? Look at DNA, whatever, there are many things, where is the hair, where the whatever, and figure out what is the most appropriate. Okay? Right? Because at the end of the day, if you go to the matchmaker, right, they will ask you a bunch of questions, right? And then actually the matchmaker will run a regression in her head, right? And then try to look at his data, who is going to match, right? But they only ask you a number of questions, human regression, right? But you can imagine this, oh, there's a huge number of the data, right? You can do that. Now, this one we will talk about that because this the most basic machine learning model. And then after that, we will learn chapter 8 is something that is one of the very important thing is we learn regression tree and random forest. The main idea is this more machine learning is you can see it's nonlinear regression. Okay, regression figure a line. Okay, you can imagine simplest thing is instead of the easiest thing you can imagine is instead of running a line are now non-linear thing. So the easiest thing is like the, let me draw a picture. The easiest thing you can imagine, we have X and Y, bunch of dot here. Okay. Okay. A regression tree in this single variable case will be I dividing a tree, means I dividing the scenario based on X. Okay. It means that I would think here is one category. Here I have the other category, and here other category. But the category form a tree, right? So first I say, is it less than this number? Yes or no? And here yes or no. So it will be somewhat how we divide. How we divide is following a tree, and then you check for protection. Okay. So just I don't know how to say, but it's like the kindergarten game, right? Just look at whether you're satisfied this, go here, 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 here. Okay. So you form a model like this. I hope that make a lot of sense what we're doing for the rest, because and then this will be the learning the machine learning algorithm. And the last lesson 9 will be doing a little bit more complicated. Go back to regression again, because we've done machine learning, right? Machine learning is good for prediction. Okay, there's no doubt machine learning is very good. But machine learning is not doing good in terms of uncovering causal relationship. Whether X caused to Y, I don't know. Machine learning is only good to say this X, you have this Y. Okay, cannot say whether actually the spin or not, right? Because there's something kind of observe. Machine learning cannot say actually Z is increasing X and Y, right? Because you can't observe Z from the data, right? So the idea of the last 2 chapters is to try to give you some idea that how you can say from the data, you can draw causality. Okay, that is the we will learn how to draw causality, and the main thing we do is to tell you that when you should put in the regression, what variables will put in regression, because as I said, sorry, jump back to the data, is as a Y plus of X, right? But you are not told that when you try to discover things, you have to make assumption whether X1 should be there, X2 should not be there, X3 should be there. What should be included, what should be included. Okay, that's human learning, but learning just for prediction, right? Which is predict best. But whether you should do it should be based on theory. Theory or your common sense can tell you what should be in X, what should it. Okay. It's a little bit abstract, but I will give you more concrete story when it goes. Okay. So the very last topic in the time is called difference and panel data. And in ITM, when you IT data, these two are very convenient, right? The first one is panel data. Panel data is you observe the same individual many times, but you have many individuals observed many times. Okay, which is ID data, right? You observe many users over time. And with the panel data, you can establish causality. Not fully, but you have some confidence that your thing will hold very well. Because one of the main reasons why your data doesn't establish causality is usually unobserved variable, right? Because I look at this guy, he do some crazy thing, right? And maybe there's something I don't know, right? There's some other explanation, right? For example, I think this is the easiest thing, okay? Is there's always a case, a woman in a movie, her husband cheat, dishonest, okay? And it is not just one. The first husband did that, the second husband did that, the third husband did that, and he declared in the movie that every men are bad, right? So that is very normal, right? I think you watched this many times, right? this kind of movie, right? Then the question would be, okay, can we conclude that, right? Say 3 may be not enough. You may say she has 100 husbands, all husband are disloyal. Can we still conclude man is bad, right? Well, put it this way, even more extreme. Suppose he married every man in the world, okay, and every man is disloyal to her. So can you conclude that men are bad? No, right? Because maybe this woman is crazy, right? You don't know whether the woman is crazy, right? The woman actually beat her husband every day, right? 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 Then the husband become crazy. That's normal, right? So that's why if someone is unobserved, you can't conclude. The good thing about panel is to control it because you observe the same guy over time. So then you can ignore something unobserved because many people. So individual character is gone. So that is one thing. The other is difference, right? Also is very useful, right? And this is useful because you control other things. That is what you do in science, right? You want to see whether medicine is useful or not. How you do that, right? Is you try to look at the case. Do it 2 patients, right? And one patient get the medicine, the other patient get the placebo, where's some of the medicine, right? And if that compare 2 guys, before and after, you have a control group, that's called difference, right? And I do remember, probably you guys are too young, but I do remember one famous drama from Korea, and there's a woman, okay, and he lost memory, and he loved a guy, okay, and that guy is very similar to his ex-boyfriend, and then he's not very sure that whether he loved him because he looks like his boyfriend, right? Then at the end, before he get married, then he get back his memory. Then he makes sure that it is not about his ex-boyfriend, so they get married. So this is a Korean drama. I don't know whether you still remember something like that, because you're going to make sure that compare before and after is very useful, right? And also there's some case, right? A woman before they get married, want to test the man, right? Whether actually he loves her or not, right? And then he tried to do various crazy things, like to test her boyfriend, right? And that's for different, right? Try to see, compare and contrast, see whether they will be working. So that would be end today. So I will be seeing you after 2 weeks time. Then you will be having the assignment. Don't worry, just Python code. So I mean, I would expect you finish within an hour. The Python assignment. If you spend more than 1 hour, then you should be careful. Okay? So I see you 2 weeks time. So see you next time.